Mm, Good evening, friends. So today we will see the topic that is set, right? What is set and different types of the set, right? So before that, first, what is mean by set? So set is the collection of distinct element, right? And it is represented by any capital letters, that is from A to Z, right? And the elements of a set is represented by small letter A to Z, right? So we can say that A is equal to opening brace and this is closing brace. So A is the name of set, equal to this is opening brace, this is closing brace, and in that we can list out the elements of that set, that is 1 comma 2 comma 3 comma 4 comma 5, etc., right? So this is nothing but the elements. It is also called as elements or object or member, right? And these are separated by commas. Again we can say that set B is equal to A comma B comma C comma D, right? Again it is the set of, consider next set C is equal to, for example, Ajay, again Rahul, right? Again Suraj, right? So this type of representation is called as tabular form, right? This is called as tabular form of representation, right? Same we can represent by using second form is builder form, right? In builder form we consider the elements of a set as a x, and its property is considered as p of x is the property of that element. For example, consider n is the set of natural number 1 comma 2 comma 3 comma 4 comma dash 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 up to n, right? This is the representation in tabular form. Now in builder form, n is equal to opening brace closing brace, and consider these 1 2 3 4 up to n as x, then vertical line, that is such that, and property of that x. What is the property of x? So x is a natural number. This is the property of x. X is a natural number. X is a natural number, right? So this representation of a set is called as builder form, right? So there are two form of the representation of a set. First is tabular form, in that the elements are listed out within opening brace and closing brace, and elements are separated by comma. And in builder form we represent in opening brace, in closing brace. First consider x as an element such that after that the property of that element, right? Now the next one is type of sets types of sets, right? So first one is null set. It is also called as void set or empty set or empty set, right? So how we can define this null set, empty set or void set? A set having no element is called as empty set, right? A set which having no element is called as empty set, and it is denoted by phi or opening and closing that empty set, right? So in this way we can represent null set. It is also called as void set. It is also called as empty set. The set which having no element is called as empty set or null set or void set, and it is denoted by phi or empty set, opening braces and closing brace, right? So any example? See example, set A is equal to opening brace x such that x is an even number, x is an even number not divisible by 2, not divisible by 2. So this is the example of null set. A is equal to x such that x is an even number not divisible by 2, right? So what is the output? Output is empty set, right? Because every even number is divisible by 2, but the condition is that x is an even number not divisible by 2. So in that set there is no any element, right? So A is equal to null or empty set. Next set is Singleton set. Singleton set. So how we can define this set? A set having single element is called as Singleton set, right? A set having single element is called as Singleton set, and example is A is equal to x such that x is Prime Minister of India. X is a Prime Minister, or we can say that present Prime Minister of India, right? So it contains single element, so we can say that this is the Singleton set, right? Or A is equal to 1. So set A which contain single element is called as Singleton set, right? Now consider next one is finite set. Next one is finite set. So how we can define the finite set? A set having finite number of elements is called as finite set, right? A set which having finite number of element is called as finite set, and element of that set, the element of that set can be counted, right? A set having finite number of element is called as finite set, and element of that set can be counted. For example, A is equal to 1 3 5 7 9, right? So this is the set which contain odd numbers, right? That is 1 3 5 7 9, which contain 5 element, so it is countable. So we can say that this is the finite set. Or again, consider another set b is equal to 5, then this is also finite set because b is the set which contain 0 element, right? So we can say that this is the finite set. So how we can define? We can define the finite set: a set having finite number of element is called as finite set, and the elements of finite set can be counted, right? Now next type is infinite set. Infinite set. So infinite set is again opposite to finite set. A set which having infinite number of elements is called as infinite set, and the element of infinite set cannot be counted, right? A set which having infinite number of elements is called as infinite set, and elements of infinite set cannot be counted. For example, n is the set of natural number, that is 1 comma 2 comma 3 dash 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 up to the n, right? Up to the n. So this is considered as infinite set, right? Now next type is again subset. Next one is subset, right? Subset. So how we can define the subset? A set, again a set a set A is said to be a set A is said to be a subset of set B. A set A is said to be a subset of set B, right? If, what is condition? If all elements of set A, if all elements of set A is present, all element of set A is present in set B, right? If all element of set A is present in set B, means if x belongs to A, then x should be belongs to B. Then x should be belongs to B. Then we can say that the set A is subset of set B, and it is represented by A subset B, and it is represented by A subset B. Example, consider example: A is equal to 1 comma 2 and B is equal to 1 comma 2 comma 3 comma 4, right? Then we can say that A is subset of B, right? A is subset of B. So next one is proper subset. So in that case, set A is said to be proper subset of set B. Set A is said to be a proper subset of set B if every element of set A is an element of set B. If every element of set A is an element of set B, means for all x which is belongs to A, right? Then again for all x which is also belongs to B. This is first condition. And second one, the set B, right? Second condition is set B, which has at least one element, set B which has at least one element which is not belongs to A, which is not belongs to A, means set B which has at least one element which is present in set B but which is not present in set A. For example, consider if A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, then we can say that A is proper subset of B, and this is the symbol to represent the proper subset, right? So in that case there is one element, that is 4, which is belongs to B but which is not present in set A, means which is not belongs to A. Then in that case we can say that A is proper subset of B, right? Now next type is comparable set. Next one is comparable sets, right? So how we can define this set, comparable set? Two set A and B, are said to be comparable if either of these happens. The two set A and B is said to be comparable set if either of these is happen, that is either A is proper subset of B or B is proper subset of A, or A is equal to B. If out of these three, if any one condition satisfy, then we can say that these two set are comparable set. Either A is proper subset of B or B is proper subset of A, or A is equal to B. Either of these is happen, then we can say that these set A and B are comparable set, right? Now next type is universal set. Next one is universal set, right? So universal set we can define as a set which is superset of all the sets under consideration is known as universal set, right? A set which is superset of all the sets under consideration is known as universal set, and it is denoted by capital S or capital U, right? It is denoted by either capital S or capital U. Example, consider n is the set of natural number, that is 1, 2, 3 up to n is the set of natural number, and consider capital E is the set of even number, that is 2, 4, 6, 8, like that, right? And O is the set of odd numbers, that is 1, 3, 5, etc. So we can say that n is the universal set of E and O, because it is the n is the superset of E as well as n is the superset of O. So we can say that n is the universal set, and it is denoted by either capital S or capital U. Now last type is power sets, right? Then how we can define this power set? A set of all subset of given set A is said to be a power set of set A. So power set of set A is nothing but it is the set of all subset of set A, right? So power set is nothing but set of all subset of set A, and generally it is denoted by P of A. So P of A is equal to set of all the subset of A. Now consider example A is equal to 1 comma 2. Then what are the subset of A? First one, consider A1 is 1, right? Again A2 is another subset, that is 2, right? Again A3 is another subset, 1 2, again this is the subset of A. And last 5 or empty set. And because empty set is by default subset of any set, that is we can say that is empty set is subset of A, right? Again 1 is subset of A1, right? Because 1 is present in set A. Then 2 is subset of this 1 2, because 2 is present in this. So 1 2 is also subset of 1 2, that is A3 is subset of A. We can say that A3 is subset of A, because every set is subset of itself. So A3 is subset of A. So by definition power set is equal to, it is the collection of all subset of set A. So P of A is equal to, first 5, by default it is subset of A. Then second subset is 1, then 2, and then 1 comma 2, right? So this is the power set of A. So there is general definition, P of A is equal to 2 raised to n. So by using this formula we can calculate the number of elements present in power set. So n is number of elements of a set A, right? So here what is the value of n? Here n is 2 element, 1 2, so n is 2, therefore 2 raised to 2, that is 4. So 4 element should be present in power set of A. So 1 2 3 and 4, right? This is the formula to calculate the number of elements present in the power set, right? So this is about set and its different types, right? So we can say that this is the basic about the set. Okay, thank you.